the skewness of the distribution of a random variable big Y is skewness equals big E open bracket open big Y minus mu sub big Y close to the power 3 close bracket over sigma sub big Y to the power 3. Equation 2.14, where sigma sub big Y is the standard deviation of big Y for a symmetric distribution. A value of big Y, a given amount above its mean, is just as likely as the value of big Y, the same amount below its mean. If so, then positive values of open big Y minus mu sub big Y close to the power 3 or cubed will be offset on average open in expectation close by equally likely negative values. Thus, for a symmetric distribution, big E open big Y minus mu sub big Y close cubed equals 0. The skewness of a symmetric distribution is 0. If a distribution is not symmetric, then a positive value of open big Y minus mu sub big Y close cubed generally is not offset on average by an equally likely negative value. So the skewness is non-zero for a distribution that is not symmetric. Dividing by sigma sub big Y cubed in the denominator of equation 2.14 cancels the units big Y cubed in the numerator, so the skewness is unit free. In other words, changing the units of big Y does not change its skewness. Below each of the 4 distributions in figure 2.3 is its skewness. If a distribution has a long right tail, positive values of open big Y minus mu sub big Y close cubed are not fully offset by negative values, and the skewness is positive. If a distribution has a long left tail, its skewness is negative. Kurtosis. The kurtosis of a distribution is a measure of how much mass is in its tails, and therefore is a measure of how much of the variance of big Y arises from extreme values. An extreme value of big Y is called an outlier. The greater the kurtosis of a distribution, the more likely are outliers. The kurtosis of the distribution of big Y is kurtosis equals big E open bracket open big Y minus mu sub big Y close to the power 4 close bracket over sigma sub big Y to the power 4, equation 2.15. If a distribution has a large amount of mass in its tails, then some extreme departures of big Y from its mean are likely, and these departures will lead to large values on average in expectation of open big Y minus mu sub big Y close to the power 4. Thus, for a distribution with a large amount of mass in its tails, the kurtosis will be large because open big Y minus mu sub big Y close to the power 4 cannot be negative. The kurtosis cannot be negative.